Hello! Today we are going to talk about adding fractions. So let's start by taking a look at a couple of pictures of fractions. So right here we're going to picture that this entire box is a whole. So right here we have a whole, and we've divided it into 5 pieces, so each one of these is 1/5. So I'm going to call this 1/5. And over here, since I have 2 boxes filled in, this is going to be 2/5. So now let's see what would happen if we added these two fractions together. So first, I'm just going to go ahead and combine these two together, these squares together, in a new picture. So I'll start by filling in 1 square for 1/5, and then I'll fill in another 2 squares for 2/5. So when we add these two things together, we're just combining them into one big group. So now we've got 3 3/5. So it's pretty easy to add these two fractions together because we started out with the same size pieces. This was 1/5 of a rectangle. Each of these was 1/5 of a rectangle, so we could just count up the total number of boxes that we started with to give us our final answer. 1, 2, 3 gave us 3/5. What we're going to find a little bit more challenging is when we're faced with two pieces that are not the same size. So right here we're having a circle represent the whole, and half of it is filled in yellow, so this is going to be 1/2. And over here, we have 1/3 of the circle filled in yellow, so this is 1/3. Now when we go to add these two together, we can draw what they look like together, but it's not very clear exactly how much of the circle is filled in, because I've got these different size pieces, and the sliver that's left, I don't know exactly how big it is, so I'm still kind of thinking, I got some questions about what's happening in this picture. So, in order to figure out how much we get when we add these two together, it would actually be easiest if we started out by breaking these down into equal size pieces. So just like it was really easy for us to solve when we had equal size pieces in the beginning, right now we're going to force the problem to look like that. Make it so that we have equal sized pieces. So on this one, I'm just going to go ahead and divide it in half, divide this third that I have in my picture, I'm going to divide it in half. And so now we can see that I've got 2 pieces here, and each of those is a size of 1/6 of the total circle. So now I've changed this one into 2/6, just done the reverse of reducing this fraction. And then over here, in order to make equal sized pieces of that, I'm actually going to divide this into thirds and divide the other side into thirds as well. So now again I've got 6 pieces. My lines are not super straight, but I think you can get the idea that each of these should be about 1/6. So now I've got 3/6. So if I combine those two together, then I should have 3 plus 2 is 5/6. Let's see if we can make the picture actually look like we've got 5/6. So I'll go ahead and draw a line right here, and a line right here, and a line right here. So now I've got 1, 2, 3, 4, 5, 6 pieces, and 1, 2, 3, 4, 5 of them are filled in. So I've got 5/6. Now I want you to notice right here that I've got 6, and 6 is a multiple of 3 and 2, the numbers that I started out with. And that's going to be a really important key as we go on to solve more problems with fractions. We're going to be looking for a denominator that is a multiple of whatever numbers we started out with in the denominator. And we are going to call this a least common multiple. So least common multiple means that it is a multiple of both 2 and 3. That's where the common multiple comes from. And least right here comes from the fact that we don't want to pick a really big number to be on bottom here. Like we could have picked 12, and that would have been a common multiple, but then we would have to be slicing this into a lot of really small pieces, and we'd have big numbers, and it just really wouldn't be worth it. We don't need that. All that we need is 6. So that's why we have the least common multiple. We're going to be looking for the smallest number that is both a multiple of 2 and a multiple of 3, or a multiple of whatever two numbers we're starting with in the denominators of our fractions. Okay, so let's go ahead and talk about what steps we're going to need every time we solve an adding fractions problem. So our first step is going to be if we have a mixed number, make it into an improper fraction. So this one, we haven't really seen an example of that yet, but we'll get to it later, and I just want you to keep that in mind. If you have a mixed number, it'll be a lot easier to deal with adding if we start by turning it into an improper fraction. And that'll also help us when we get to subtracting to try and keep things straight. Okay, so that's our first step. And then our second step is to make equal size pieces. So like we saw up above, this making equal size pieces makes it easier to add them together. And we normally call this find the least common denominator. So turn them both into fractions that have the same number in the denominator, and that denominator is going to be a multiple of both of the original denominators. Okay, so then our next step is going to be to add the numerators. Remember, the numerator is the number on top, and we're going to keep the denominator the same. So in this step, the denominator, the number on the bottom, shouldn't be changing at all. So you can see once we got this common number of 6 on the bottom, that 6 stayed in our final answer. We just had to add how many pieces we had. But the size, saying that each piece was 1/6, the size of the pieces is not changing in this step. Okay. And then our last step is just going to be cleaning up our answer, and that's going to be reduce if needed, and we want to put back in mixed number if needed. So this second part right here, we're only going to need to put it back in a mixed number if we started out with mixed numbers in the original problem, and if our number is big enough that it's bigger than 1 and we can actually write it as a mixed number. Anytime you've got a tiny fraction like 1/4, this is just going to be 0 and 1/4. You can't really say that it's 1 in anything or 2 in anything. It's too small to even add up to 1. So this put it into a mixed number if needed is only going to be necessary if we have big numbers and we started with mixed numbers in the original problem. That normally means that we're working in a context where it's necessary to have mixed numbers. Okay, so let's go ahead and try another example of this. So I'm going to do 1/5 plus 1/4. Okay, so it looks like our first step is to make it into an improper fraction if we have mixed numbers. But we don't have any mixed numbers, so we can go ahead and go on to the next step. The next step is to make equal-sized pieces, which means find the least common denominator. So for that, remember I need to find a number that's a multiple of 4 and a multiple of 5. So, on the left-hand side here, I'm going to list out a bunch of different numbers that are multiples of 5. Got 5, 10, 15, 20, 25, 30. Might need to go a little bit higher, but I think that's a good start. Let's see if we can find anything in common when we list out our multiples of 4. So for multiples of 4, I've got 4, and then 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. Ooh, that sounds familiar. Look at it, I've got a 20 over here, and a 20 over here. So it looks to me like I'm going to be trying to find 20 as my denominator for both of these fractions. So I'm going to go ahead and write that out. And just like when we were doing reducing fractions, we had to divide the top and the bottom by the same thing. Here, since we're trying to make the bottom a bigger number, we're going to multiply the top and the bottom by the same thing. So I'm going to multiply the top by 4, I'm going to multiply the bottom by 4, and over here I'm going to multiply the top by 5 and the bottom by 5. So by doing that, on the bottom I'll have 5 times 4 will give me 20, and I'll have 1 times 4 will give me 4 on top, and that's the 20 that I'm hoping for on the bottom. And then over here, I'll do 1 times 5 is 5, 4 times 5 is 20, and again, that's the 20 that I'm hoping for on the bottom. So I picked out 5 times 4 because I knew it would give me 20, and 4 times 5 because I knew it would give me 20. Whatever I multiply on the bottom, I have to multiply by the exact same thing on the top. So now we've got our equal-sized pieces. This is the same as cutting these pieces down into smaller pieces. So I've got 4/20 plus 5/20. So now that I have matching denominators, my next step is to add the numerators and to keep the denominators the same. So I'll go ahead and add the numerators. I'll do 4 plus 5 is going to give me 9, and I'll keep the denominator the same. So my denominator started out being 20, and it's going to stay 20. Okay, so now I'll go back up, see what my last step is, and it says reduce if needed. Okay, so this number on top, 9, that's only divisible by 3. Yeah, 3 times 3, it's divisible by 9. And on bottom, this is going to be divisible by 2, and 4, and 5, and 10. So I'm not seeing anything that these two have in common, so I'm not going to be able to reduce this fraction any farther. And it says put it back in a mixed number if needed. Well, this is definitely smaller than 1, so I'm not going to be able to put this into a mixed number. So I think that this is going to be my final answer. Dun 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 dun! Okay, so let's go on ahead to this next problem. You go ahead and pause this video and try it on your own. So go ahead and pause, and we will come back together once you are finished with that. Okay, so now that you have tried this problem on your own, we're going to go ahead and do it together. So here we're starting out with 1/4 plus 1/3. So remember, the first thing that we want to do is turn these from mixed numbers into improper fractions if needed. And here it's not needed because we're not really starting out with any mixed numbers. So then our second step is to find a least common multiple, an LCM, a multiple of both 4 and 3. So let's start out listing out some numbers so that we can find a multiple that's a multiple of both of those. So we'll start out on the left-hand side, going off of 4. I've got 4, 8, 12, 16, 20, 24. That'll probably be big enough. So let's go over here. We'll list out some multiples of 3. So I've got 3, 6, 9, 12. Ooh, good. Now I have a match. 12 and 12. Okay. So I want to show you guys that we could keep going over here. We get to 15, 18, 21, 24. And this would be another match, 24 and 24. But our least common multiple means that we're trying to find the smallest number that's both a multiple of 4 and a multiple of 3. So I'm going to pick 12, because 12 matches on both, and it's the smallest number I can find that will do that for me. Okay, so now that we've found our least common multiple, I want to actually make that the denominator on both of these. So let's go ahead over here. In order to get a 12 on the bottom, I'll have to do 4 times 3. And if I multiply the bottom by 3, I also have to multiply the top by 3. So then I'll be doing 3 times 1 will give me 3. And then over here, in order to get a 12 on the bottom, I need to multiply by 4. If I multiply the bottom by 4, I also have to multiply the top by 4. So 1 times 4 will give me 4. Okay, and then our next step, once we have these set up with a common denominator, our least common denominator, is going to be to add the numerators and keep the denominators the same. So we'll go ahead and do 3 plus 4 is giving me 7 on top. And the denominator is going to stay the same, so it'll stay 12. Our pieces are staying the same size. Pieces are 1/12 of the whole. Okay, so then our final step is going to be reducing this fraction and turning it into a mixed number as needed. So looks like 7, that one's a prime number, so it's only going to be divisible by 7. The bottom is divisible by 2 and 3 and 4 and 6, but it's not divisible by 7. So I'm not going to be able to divide anything out of this fraction. And again, it's smaller than 1, so we're not going to be able to turn this into a mixed number. And this right here will be my final answer. Okay, so let's go on to do another example. So this one is 5/6 plus 5/8. 5/6 plus 5/8. Okay, so remember our first step is to find a least common denominator, number that's a multiple of 6, and it's a multiple of 8. So I'll list out my multiples of 6 over here. I've got 6, 12, 18, 24, 30, 36. Okay, and then I'll see if there's anything that matches over here and keep going if I have to. So for 8, I've got 8, 16, 24. Hey, there's a match. Got 24 over on this side, 24 over on this side. Okay, so now we found a number that's a multiple of 6 and a multiple of 8. So we'll go ahead and make that our new denominator. So in order to get a 24 on the bottom on this side, I'm going to have to multiply the bottom by 4. If I multiply the bottom by 4, multiply the top by 4 as well. 5 times 4 will give me 20. Then over here, to get a 24, I'm just going to have to multiply by 3. So if I multiply the bottom by 3, I also multiply the top by 3. So then I will have 24 on the bottom and 15 on top. My next step is to add the numerators together and keep the denominator the same. Our size pieces will stay the same. We'll stay with 24ths out of the whole. So this will be 20 plus 15 will be 35 out of 24. Okay, so then our last step is to see if we can reduce this, and if needed, we'll turn it into a mixed number. So, right here it looks like I've got 35 out of 24. So 35 is divisible by 5 and divisible by 7, and 24 is divisible by 2 and 3 and 4 and 6 and 8 and 12. But I'm not seeing anything that they have in common, because this bottom is definitely not divisible by 5, definitely not divisible by 7. So we're not going to be able to reduce this fraction. So that could easily be our final answer, but in some contexts, it will be necessary for us to put it in mixed numbers. If you're working with something like measuring inches, don't know why you'd have a 24th of an inch, but just as practice, we'll go ahead and make this into a mixed number so we can get a little bit more practice with that. So if we wanted to turn this into a mixed number, we would say, okay, how many times does 24 go into 35? It's always we're dividing the number on the bottom into the number on top. How many times does 24 go into 35? It only goes in once. So then I'll subtract out 24, and I'll be left with 11 pieces. So then I should have 1 as my whole number, and I have a leftover of 11 pieces out of this 24. So 1 and 11 24ths. That would be how I'd write this answer as a mixed number if I needed that for some reason. Okay, so let's go on to our last practice problem. Oh, nope, got some more down there, sorry. Okay, let's go on to another practice problem. So I'll go ahead and pause for a second and let you guys solve this one. Okay, so here we're doing 3/4 plus 5/6. So on this one, we're looking for first making sure that these are improper fractions if they started out as mixed numbers, but we aren't starting with mixed numbers, so we can go on to the next step, which is find the least common denominator, number that's a multiple of 4 and 6. So here I've got 4, 8, 12, 16, 20, 24, and my multiples of 6 are going to be 6, 12, wow, there's a match already. I just need to get it into 12ths. Okay, so on this side, in order to get 12 on the bottom, I will multiply the bottom by 3. If I multiply the bottom by 3, multiply the top by 3, and I will get 9 on top. Over here I'll have to multiply the bottom by 2, which means I also multiply the top by 2. So then I've got 12 on the bottom and 10 on top. So now I've got 9 twelfths plus 10 twelfths. So next I'm going to add the numerators together and keep the denominator the same. So I'll have 19 twelfths. Okay, and then our last step is going to be checking if this reduces and seeing if we can turn it into a mixed number. So for this one, 19 and 12, 19 is a prime number, and 12 is smaller than 19, so it's definitely not going to be divisible by 19, so we can't reduce this any farther. So this could be a good final answer, and if someone asked us to put it into a mixed number, then we want to say 12 goes into 19, it'll only go in once, so then we'll have subtract 12, remainder of 7, so 1 will be our whole number, and we will have 7 out of 12 left over, so 7 twelfths. So that would be how we would write it if we were asked to put this answer as a mixed number. But most of the time, an improper fraction will do just fine. Okay. So now, let's go ahead and look at this example. this example is actually starting with a mixed number, so we are going to have to turn this into an improper fraction. So I'll have to start by multiplying the whole number times the denominator on this one, which will give me 9, and then I'll add the numerator. 9 plus 2 will give me 11, and then I take that 11 and put it back over the original denominator, which is 9. Okay, and I'll take this, and that will be the other number that I'm adding together here. So we've got 5/4 plus 11/9. So this one already started out as an improper fraction. Okay, so right here we're going to find a common multiple of 4 and 9. So I've got 4, 8, 12, 16, 20, 24, 28, 32, 36. And then over here I'll have 9, 18, 27, 36. There we go, matching 36. Okay, so this one, in order to get a 36 on the bottom, I'm going to have to multiply the bottom by 9, multiply the top by 9, and we'll get 45 on top. And over here, I'll have to multiply the bottom by 4 in order to get a 36 on the bottom. And I'll multiply the top by 4, get a 44 on top. Okay, so now we've got 45 plus 44, and that will give me 89 on top, and the denominator stays the same, so that'll be 36. Okay, so there is a pretty good answer, but this one is an improper fraction. And since we had a mixed number in our original problem, it's pretty likely that we're going to need this back as an improper fraction, or as a mixed number. So I'll go ahead and say, how many times does 36 go into 89? Always, how many times does the bottom go into the top? So it looks like this is going to go in twice, and that'll give me 2, carry the 1, 7. So when I subtract, then I'll have 9 minus 2 is 7, 8 minus 7 is 1. Okay, so this is going to be equal to 2 and 17 out of 36. Okay. And these numbers are not going to be able to reduce. The bottom is divisible by 2 and 3 and 4 and 6. Top is not divisible by 2 or 3 or 4 or 6. Yeah, I'm not seeing anything that they have in common here, and the 17 as well is not going to be divisible by anything that's also going to go into 36. So this would be my final answer. Probably a mixed number is what we're looking for, since we had one of those in our original problem. Okay, so then let's go ahead and do some more practice. And I will go ahead and pause for a minute and let you solve this one on your own. Okay, so this one is going to start out making us turn this into an improper fraction. So in order to do that, we'll have to do 1 times 5 equals 5, and then after that we'll do 5 plus the one that we started with on top will give us 6. So now we have 6/5. Okay, so I've got 4/3 plus 6/5. So my multiples of 3 are 3, 6, 9, 12, 15. Over here I've got 5, 10, 15. Ooh, there's a match. Okay, so my left-hand side, in order to get 15 on the bottom, I'll have to multiply the top and the bottom by 5. So I've got 20 out of 15. On the right-hand side, in order to get 15, I have to multiply by 3. Multiply both the top and the bottom by 3. So I've got 15 the bottom, 18 on the top, and I'll add these two together. So when we add these two together, we want to add our numerators and keep the denominators the same. So here I've got 38 out of 15. So our last step is reduce and make into a mixed number if necessary. So with 38 divided by 15, the top is divisible by 2, and maybe some other number, but it looks like it'd probably have to be a pretty big number. The bottom is divisible by 3 and 5. Yeah, I definitely can't divide 3 or 5 into the top, so I'm not going to be able to reduce this any farther. But it does look like 38 is bigger than 15, so I could turn this into a mixed number. 15 will go into 38, will go in twice. We'll be left with 30 on the bottom, subtracts to give me 8. So I've got 8 pieces left over out of 15. Our size is still 15ths. So then 2 and 8 15ths will be a good final answer for this one. Okay, so this is the end of the official lesson on adding fractions, but if you feel like you need some more practice, you can go ahead and keep watching the video. I'm going to go ahead and give you a second to pause and try some of these problems on your own, and then I will solve them quietly, but you can still see what answers you should be getting.